Hello my dear students, welcome to our program today in chemistry, third secondary stage.
It's nice to meet you for this wonderful lesson. Let's go.
Cations and anions, cations and anions, they are big difference between them. We have this part is very important for you. Let's see videos and our part of this cations and anions for what? For the reactions and the equations.
Anion, it's easy to say you have a negative charge. Negative charge for each part for an ion. Anions, it has main part of the reaction, main important for the equation. Catch it, my lovely students, and make it excellent equation to obtain full mark.
Let's start our tests and videos. Let's go. We have lead 2 sulfate.
Lead 2 sulfate, it means it has a formula. Do you remember the formula?
Yes, we have PPSO4.
Good. Let's fly to see this. Oh, salt solution and the solution. What I want from this, I want to write
the solution and the solution symbols and the equation.
Good. The equation here must begin with both. Now, salt solution plus mean 1, it means lead acetate. You remember? Do you think what happened now will give?
Give white PPT of what? Of another compound of lead acetate.
Solution. Good. It's good to say all of them, but you must concentrate for this reaction. Na2SO4 in aqueous solution plus lead acetate CH3 COO all by 2 PP. This is aqueous one. Product will be
2 molecules of CH3COONA sodium acetate and in aqueous solution, and we have PPSO4. It is lead sulfate, lead 2 sulfate.
It's good to say that, but tell me what is the important substance here of the important solution? I don't understand one. What is the most important one?
It's lead sulfate here.
But I say it's a solution. Do you think it's a solution?
No, it is solid state or precipitate.
It's good to say all of them. Now, what about to get this?
Second, we have analytical group.
Analytical group? Do you think we travel to the other part of the lesson? This is anions? Do you think it's anions?
No, they are called cations.
I don't understand this well, but tell me what is the cations after this group? Look at this. Oh, qualitative analysis of the cations. I think this word, the cation, in the whole world, China, Egypt, everywhere, it means
the positive ions of the experiment show in this package may both the certain part or the certain part of the compounds.
It's good to say that. You must contain the positive charge. We get different tubes, as you see for this video. Identify the common cations, different one, analyzed, and what cation is present in the sample.
We can carry out the flame test, and we have some kind of this flame testing chemically change to observe the products and the following parts.
Expect the observation to write what your conclusion. The first one, aluminium. What do you see?
Aluminium ion is colorless cation. Sodium hydroxide solution of aqueous ammonia can be used for this testing.
Add sodium hydroxide solution. We will see formation of white precipitate of aluminium. Aluminium hydroxide, by the excess of sodium hydroxide, will give me
the white precipitate.
The white precipitate especially, and disappear by excess of
NaOH.
It's good to say that because formation of aluminium hydroxide. Now you have
aqueous ammonia is
used for this reaction, and we add aluminium hydroxide. This reaction, excess of the ammonia is added. By the same and last equation, formation of the color is
white color. We have the reaction of Al positive 3, and we have the equation Al positive 3 with NaOH and the excess of NaOH. We have the precipitate or white precipitate of this reaction. It can be identified another one of these tests.
This test about the calcium, directly we have holder and we try to heat it on the flame. From the time to time, I want to know what happened. I added to the water to be solution and the further by sodium sulfate. White precipitate will be formed, but this reaction of the calcium sulfate is insolubly water, not soluble. So the reaction here is not complete.
So the calcium positive 2 aqueous solution plus SO4 negative 2 aqueous solution give us calcium sulfate in the precipitate.
What about the copper 2 ion? It's a copper 2 ions blue. Blue for dry test. Look at this. When you heat the copper for this flame, give you this wonderful blue color. Try to close to green. Now, when you add more of sodium hydroxide to the solution, you can see the color is changed into
green color or green blue color.
It's good, but we say gelatinous one. The equation?
In Cu positive 2 aqueous solution, we have NaOH that give us copper hydroxide solution.
What happens if you add more ammonia? The aqueous solution here, the color is changed into
blue color.
Good. This it means we have a copper. Excess of ammonia is added. For this case, the precipitate will dissolve. So, when you make treatment for this solution for the blue color and add more, will be more dark. Equation?
We have the copper and NH3 aqueous solution, and we have the copper hydroxide soluble
with ammonia, and they give this color and they change it into different color. The other one for iron 2 anion. Iron 2 add sodium hydroxide solution containing iron 2 ion. See, what is the color for this case?
This color is green color.
Is not completely green. It's whitish one. We say green whitish. So precipitate will not dissolve. Do you think why? Like aluminum. Now, what happens when you add more ammonia?
In the color is change into black color.
So Fe plus NH3 directly iron hydroxide and ammonia aqueous. What about the third one?
We have iron 3 and the ion is a pale yellow ion. So the sodium hydroxide solution is added to the solution containing iron 3. What is the color here?
The color is changed to the brown. As you see, we can say reddish brown. So iron 3 hydroxide, a special color by the excess of the alkaline solution, the precipitate also not dissolved. But when you add ammonia for this solution, you can notice this color start to be changed and concentrated. Directly we say
Fe3 aqueous solution with ammonia give us iron hydroxide 3, and we have the ammonium solution that's appear. And we have another one, the zinc ion is colorless ion. What will happen here?
For this equation, add sodium hydroxide as usual, as we do it all time, and we see the changing for the color. It's a gelatinous one, so zinc hydroxide is formed. By shaking from time to time and the excess of solution added to this, do you see dissolve or not dissolve?
This is not dissolved.
No, it's dissolved. Be careful and look.
Yes, it is soluble. Zincate or zincate here in this reaction. So the equation, it will be ZnOH by 2 plus OH aqueous solution. We have ZnOH by 4. This is the solution of this compound of zinc hydroxide.
Add ammonia to zinc hydroxide and tell me what happened and what is the color now.
What is the color is what? The color is white, gelatinous one.
The excess aqueous ammonia is added to this from time to time. Directly the color will
disappear
and dissolve this, and the color is not here. You have now colorless. Equation
is ZnOH by 2 plus NH3 aqueous solution. Zn give us ZnNH3 by 4. This is the solution of the compound.
What about ammonium? Oh, ammonium, it's good. what happens if you add sodium hydroxide to ammonia? Look at this. The color gas will start to be evolved. But I don't know what this gas. But be careful for litmus paper. The color of this red litmus paper directly it changes into blue. This tell me the gas is
NH3.
This is it means alkaline gas has a colorless which it changed into blue. Blue with what? With litmus paper. What about this? It's about
the cation. This group are precipitated in the form of sulfide acidic medium by dissolving the salt in water.
It's good to say all of this. What about this? You must add dilute hydrochloric acid. This hydrochloric acid to it make a solution is acidic solution. Now, what do you see after that?
We have passing the hydrogen sulfide gas to it, and we have copper plus 2 ions or radical that in one form this group.
These groups about copper 2 cation. Catch it and concentrate it to understand what we talk about. Copper 2 cation. Catch this now.
So here we have the copper 2 cation. We have some reaction here that's happened to make what? To make detection of the copper ion.
So when you add slowly this salt make different reaction and the color blue. As you see, it means you have copper cation. When it starts to dissolve for this reaction, be sure copper cation the strongest one. Fly to this. Copper 2.
Copper 2 salt solution plus what? Group reagent HCl plus H2S. This is the reagent of this group. It's black PPT.
Good. Tell me, what is meant by group reagent?
This is the reagent here, HCl plus H2S hydrogen chloride, and in aqueous solution, and H2S hydrogen sulfide gas in black PPT.
It's good. Do you think what happened after that? From copper 2 sulfide is formed. Do you think that's only? Sure, it's not. Look at this.
Soluble, this is formed. Copper 2 sulfide is formed soluble in the hot nitric acid.
It's good to say that. My dear students, don't forget. What about the dissolving solubility for any compound we make it? Talk about solubility. Catch this one. Equation. Catch it now.
So the equation here, we have copper sulfate aqueous solution, and we have H2S gaseous state. And remember this, the state of each one of the components here of reactant and the product. What are the products here?
Product, directly you know it and everyone know it now. The first one about sulfuric acid, H2SO4 in aqueous state. The result important one for this solid state is
copper sulfate.
Copper sulfide here, it's important for indicator the sulfide group. My dear, don't forget CuS, and it has a special color. The color is
black color.
Good. What about it? To catch this now, they are precipitated as hydroxide using ammonium. Tell.
Hydroxide, if they are not mixed with other cations.
Cations here, it means what? It means positive, so cannot be mixed. Now, cations here to be studied, you must know.
We have aluminum, Al, positive 3.
Good to say, positive 3. The second one,
iron 2, Fe.
Only?
No, we have positive 2.
Third one,
we have iron 3.
Only?
No, we have positive 3.
So we did use all cations
contains positive ion, positive 2 or positive 3.
Divalent or trivalent, easy and important.
The main experiment here is salt solution plus ammonium hydroxide. This is the group reagent.
Oh, we have group reagent also here. Tell me it again, I don't understand what you tell me about.
Here we have the group reagent. It means mixing between these two compounds salt solution that contains any one of these cations, and we have the ammonium hydroxide. This is called the group reagent.
You have cation. This cation about aluminium. This aluminium, it has a symbol
Al positive 3.
It's good to say that. Do you think, what about the reaction for aluminium? Tell me now.
We have the equations here. So the equation, reaction with group reagent. So
Good. Group reagent start with this.
Al2SO4 by 3 aqueous solution. It must be aqueous solution in the presence of NH4OH, ammonium hydroxide aqueous solution.
No, this equation is not right. You must say 6 molecules of ammonium hydroxide. My dear colleague, tell me, what is the result now?
So the result here, we have 3NH4 by 2 SO4 in aqueous solution. It means ammonium sulfate aqueous solution plus 2AlOH by 3. It's what? This is aluminum hydroxide 3.
It's good to say that. This aluminum hydroxide is the important one. Why? Because we depend on
the reaction here and depend on the solid state here.
it's good and aluminum cation. Now look at this. White gelatinous PPT of aluminum hydroxide is formed. The formula will be
AlOH by 3. It means what? It means aluminum hydroxide 3.
good. The color here will be
White.
white gelatinous, my dear. Look, soluble this solution in dial acid. This acid solubility in caustic soda. I don't understand this word. Tell me what's the caustic soda.
Caustic soda, it means what? It means NaOH.
It's good to say that. So gelatinous format. Solubility, yeah, can be in presence of acid in caustic soda, sodium hydroxide. What about to fly for this?
Salt solution
Salt solution of what?
of Al positive
Depending
3.
on what? Aluminium. Aluminium, it has.
It has 3 positive charges here.
Now complete the equation.
We have the salt solution plus hydroxide. Which hydroxide? We have sodium hydroxide solution. It is the confirmatory test. So the salt solution plus the sodium hydroxide solution give us what?
Give us white gelatinous. We know that. This gelatinous depending on aluminum hydroxide. This aluminum hydroxide for the formula NaAlO2. Oh, it's not aluminum hydroxide. This is the other formula that result from sodium hydroxide and aluminum hydroxide. Do you know what this means?
We have the reaction between them. Aluminum hydroxide react with the excess of NaOH to form this compound NaAlO2.
Sodium aluminate. Good. Now, my dear, catch this reaction. Soluble this sodium aluminate in excess of hydroxide, NOH. So, directly we have new compound, sodium meta-aluminate or sodium aluminate. Easy and wonderful. Get this.
We have the equation here. The equation is Al2SO4 by 3. This is aluminum sulfate in aqueous solution plus 6 NaOH in aqueous solution also. They give us what? Give us another compounds. What are they?
The compound directly we say 3Na2SO4 aqueous solution plus 2AlOH by 3 in solid state. Oh, we like this. It's the important one is
2LaOH by 3 in solid state called aluminum hydroxide.
Why we say that? Because it has a special color. We need it all time. This color is
White gelatinous color.
it's good to understand this, which form sodium meta-aluminate in excess of sodium hydroxide. My lovely students, catch this with us. Look at this.
We have the equation here. We have AlOH by 3 in solid state, and we have 6NaOH, the excess of sodium hydroxide or caustic soda here with aluminum hydroxide. What will happen here?
Directly form sodium meta-aluminate, NaAlO2. Important one. I like this equation for this special cation about aluminum. Al positive 3. Easy and important. Fly to the other one now.
We have another one of these cations that called iron 2 or Fe positive 2.
Good, but the iron it has a 2. Fe may be positive 2 or positive 3, but we accept one. Our special one now is Fe
Positive 2.
Catch it and look. When you get it, you must write the equation as a beginning. Iron 2 sulfate FeSO4 aqueous state plus ammonium hydroxide, 2 molecules also in aqueous state. The result will be
NH4, 3 NH4 by 2 SO4. We have this is ammonium sulfate aqueous solution, and FeOH by 2, this is iron hydroxide 2 in solid state or precipitate.
good. What is the most important solution here, do you think? Solution aqueous or solid?
This is the solid is the most important one.
Is called,
FeOH by 2.
it means iron 2 hydroxide. Directly we said at this, the color will be
White precipitate or white color of iron hydroxide 2 turns white green when what? When the excess exposed to the air.
It's good to say that. Whitish green, this is we saw it before. You have white green of iron 2 hydroxide. Easy and important. My lovely student, don't forget, soluble in acid. Solubility is very important. Fly to the other one when you say
Salt solution plus the sodium hydroxide. Salt solution of what? Of the iron 2 solution, and we have the sodium hydroxide solution, a white green PPT that formed here, formed from this reaction between them.
don't forget the white green here, it means iron 2 hydroxide. Now you must know this iron 2 is formed and start to make a reaction. What about to write this equation? Now tell me what it's about.
This is FeSO4 in aqueous solution plus 2NaOH aqueous solution also to form what? To form a new compound. What are the products here?
The product directly Na2SO4 aqueous solution plus FeOH by 2. It's solid. We know it. It's an important one. Do you think what it's a color?
The color is white green.
Good to say that. The color white green, it's soluble in acids. Easy and important. My lovely students, don't forget to say
We have the iron 3 Fe positive 3 ion or radical. This is big difference between the iron positive 3 and the iron positive 2. So we have the equation and the reaction to differentiate between them.
yeah, I want to differentiate between ferrous and the ferric. It's good to say that. Iron 3, it's about equation. Write it please.
FeCl3 iron chloride 3 plus 3 NH4OH. It's the aqueous solution of ammonium hydroxide. So we have the product here.
Product, I know it, but look at this. The product here back to 3 molecules of ammonium chloride NH4Cl plus FeOH by 3. Tell me, what is the important compound for this?
This compound is what is the iron hydroxide 3 in solid state.
Good, but I think it has a color, but I don't remember the color.
The color is white green.
No, this is 3. The color, it's reddish brown gelatinous one. So, my colleague tell me the difference between FeOH2 and FeOH3.
FeOH3 here, this is reddish brown gelatinous compound or precipitate. But we have FeOH2, it's the white green color in solid state.
It's good to understand all of this. Look at this. This precipitate soluble. Soluble where?
In acids.
Oh, FeOH2, FeOH3, both of them soluble where?
Soluble in acids.
I like this lesson because it's easy and important to catch all of this. Now, look at this. We have fifth analytic group. Do you think what it's about?
This is about cations of these groups are what? Are precipitated as carbonates by addition of ammonium carbonate, and we study calcium ion as what? As an example of this group. So here calcium cation as the example of the fifth group of radicals.
Calcium, I think all of students know the calcium well, and we saw it for the movie. Tell me, the calcium has a main experiment. This main experiment, tell me, salt solution plus ammonium carbonate solution. It has an important result. Tell me, what is the result? The result, depending on the
group reagent here, it means the salt solution and the ammonium carbonate solution.
When I ask you why we say it's a group reagent, because it's
the main experiment here.
Good. Now we have a calcium. Calcium here, the important cation, it has a symbol.
We have the symbol, it's Ca.
Good. What about the valence?
Valency is positive 2.
It's good to say that we have a calcium divalent. Fly, my student, for this reaction. This reaction with a group of reagent. See and look for this.
So the equation of this one, calcium chloride CaCl2 in aqueous solution, also in aqueous solution, remember this, plus NH4 by 2 CO3 ammonium carbonate solution, aqueous solution also. They make what? They make double substitution reaction between them to form what?
To form directly ammonium chloride to NH4Cl aqueous plus calcium carbonate. But I want to ask, what is the important agent or important factor for this?
This is what? This is the calcium carbonate in solid state.
It's good to say that because we talk about calcium. So the important one for this case, calcium carbonate, easy and important. Look with me for this.
A white precipitate of calcium carbonate is formed, soluble in dilute hydrochloric acid.
I want to ask, now all cations, as you see, iron 2, iron 3, and the calcium, all of them dissolve in where?
Dissolve in dilute hydrochloric acid.
It's good to say that. Concentrate, my lovely students. Now you must add
also, and we have water containing carbon dioxide.
Do you think what is the result for this case? Look at the equation and tell me the important one.
So the equation here, the calcium carbonate in solid state plus H2O liquid state, and we have carbon dioxide in gaseous state. So here we have carbon dioxide dissolve in water. What are the products here?
The product, it's a surprise, I think you know it. The product directly for this formula, it's
calcium bicarbonate by 2. Why? Because here we have carbon dioxide dissolve in water and react with the carbonate here.
My future students, I think you understand the lesson. What about the next one? We'll know after that.
Dear friends, we hope to enjoy your time with us. Till we meet again in another episode about chemistry. Thank you and goodbye, everybody.